In 1986, workers in communist Romania were testing the ground to see if it was suitable for a power plant when they stumbled across the Movile Cave near the Black Sea at Mangalia. The Movile Cave was to be considered one of the greatest discoveries of the century that revolutionized the theories of life on Earth. Since then, the cave has remained sealed by the Romanian authorities. Fewer than 100 people have been allowed inside Movile, a number comparable to those who have been to the moon. The epochal discovery made by researcher Cristian Lascu was certified 10 years later by NASA researchers who brought to Mangalia an ultra-sophisticated mobile laboratory and a team of scientists who launched a research project in collaboration with Romanian counterparts. From a geological point of view, the cave is situated in the Moesica platform and dates back to the Quaternary. With a total length of 300 meters, it is considered relatively small, with narrow passages that make up a labyrinth of low, 1 to 2 meter galleries with a rounded profile, dug in oolitic limestone and Sarmatian limestone. To explore the rest of the cave, you must dive into the lake and navigate narrow underwater passageways, squeezing through tiny gaps in the rock before emerging into airspaces called air belts. Doing this in complete darkness is the most dangerous part of exploring the cave. You are far from the surface, so getting stuck or losing your way in the maze of tunnels would be lethal. Despite the dark and the dangerous gases, Movile Cave is crawling with life. So far 48 species have been identified, including 33 found nowhere else in the world. In 1996, researchers categorized the animals in the cave. They included 3 species of spider, a centipede, 4 species of isopod, the group that includes woodlice, a leech never seen anywhere else in the world, and an unusual-looking insect called a waterscorpion. Strangely, one of the spiders was closely related to a spider found in the Canary Islands, which lie over 4,000 kilometers to the west, off the northwest coast of Africa. The worse the air gets, the more animals there are. It's not at all obvious why that should be, or how the animals survive at all. Without sunlight, the animals in Movile Cave seem to be without a source of food. In most caves, animals get their food from the water dripping down from the surface. This water can often be seen in the form of stalactites and stalagmites. When Lascu first visited, he could not find any stalactites or stalagmites, or any other sign of water coming from the surface. That means the water isn't coming from above, so it must be coming from below. It now seems that the water in Movile Cave comes from spongy sandstones where it has lain for 25,000 years. However, this still doesn't explain how the animals in the cave survive. Tests have shown that the water flowing in does not contain any food particles. Instead, the food comes from the strange frothy foam sitting on top of the water. This floating film, which looks like wet tissue paper and can even be torn like paper, contains millions upon millions of bacteria known as autotrophs. These bacteria get their carbon from carbon dioxide just like plants do, says Bowden. The carbon dioxide level in the cave is about 100 times higher than normal air. But unlike plants, they obviously can't use photosynthesis as there is no light. Rather than using light as an energy source, the Movile bacteria use a process known as chemosynthesis. They get the energy needed from chemical reactions, the key ones being the oxidation of sulfide and similar sulfur ions into sulfuric acid, or the oxidation of ammonium found in the groundwaters to nitrate, says Bowden. These chemosynthetic bacteria help explain why the cave is so large and the air is so thick with carbon dioxide. Sulfuric acid actually erodes the limestone, which is gradually making the cave bigger, says Bowden. The process releases carbon dioxide, which is why levels are so high. Another major group of bacteria get their energy and carbon from the methane gas that bubbles up through the waters of the cave. They are called methanators. Bowden describes methanators as messy eaters that constantly leak metabolic intermediates like methanol and formate into the surrounding water. In turn, these chemicals are food for other species of bacteria. The Movile Cave microbes could also offer hints about how the first life formed on Earth, and how alien life would be also another habitable planet. They are genetically similar to those found in geothermal vents, which are also rich in carbon dioxide, sulfides and ammonia.